All right, I'm going to bounce around a little bit here just with the different ways that we can do this in the problem. So I'm going to move from left to right. So I'll go from number 1 to 4, 2 to 5, 3 to 6. For number 1a, we're looking to simplify x plus 13 all squared. So one way that you can think about this is it is the square root of x plus 13 times x plus 13. Now, if I were to ask you what is the square root of 25, my hope is that you would say 5, because in the square root, or underneath the radical there, we have 5 times 5. We can pull out one of those since there's a pair. Well, for a, x plus 13 times x plus 13 means that when we take the square root of it, we can simplify it down to simply x plus 13. And you can leave it in parentheses or not, up to you. The simplified version would be out of it. For right now, it's okay if it's in. For b, a little bit more straightforward and a little bit more what you may be used to. I'm going to write this all the way out. So for the square root of 49, we have the square root of 7 times 7. Then a squared can also be written as a times a. B to the 6th can be written as b times itself 6 times. So now we need to look for pairs. Since we're looking for a square root, we're looking for a number that multiplies by itself, and we can pull out that pair. So we can pull out a 7, an a, and here we've got 6 b's, which means that we can take half of them. We can take 3 of the b's. So we'll end up pulling a 7, an a, and 3 b's to get us 7a b cubed, or b to the 3rd power. For number 4, simplify x plus 5 times x minus 3. And you've done this in Module 1, but it's just that refresher because we're going to be using it quite a bit. So we're going to take that first term, x, and we're going to multiply it. We're going to distribute it into that second set of parentheses. X times x gives me x squared. X times negative 3 gives me minus 3x. Now for the second part, we're going to take that positive 5 and distribute it in as well. So positive 5 times x gives me positive 5x. Positive 5 times negative 3 gives me negative 15. We need to combine our like terms. We should end up with x squared plus 2x minus 15. That would be your simplified version for number 4. For number 2, what kind of function is this? And we've just spent quite a bit of time working through it. Linear, quadratic, exponential, or neither. So we're trying to look to see what we need to do to get from one step to another. And maybe this fraction is tripping you out a little bit. That's fine. Skip it for now because we're going to come back to it. If you go from 2 to 6, 6 to 18, 18 to 54, you can see that it's getting pretty big pretty quickly. Well, 2 times 3 gives me 6, 6 times 3 gives me 18, 18 times 3 gives me 54. 2/3 times 3, if you recall your fraction rules, I can cross cancel those 3's and I would end up getting 2. So 2/3 times 3 gives me 2. Because I have a common ratio here, I know that we have a quadratic, not a quadratic, an exponential function. Okay. A linear is when we're adding and subtracting, and we've got a common first difference. A quadratic is when we have a common second difference. An exponential is when we have a common ratio. And in this case, we have a common ratio of 3. For number 5, knowing what we know about number 2, write the explicit and recursive equations. So for the explicit, we already know everything that we need to know. Our f of x is going to equal, we need to figure out what happens when x equals 1. Well, the value is 2. Times our common ratio, which is 3, to the power of x minus 1. That is your explicit equation. For the recursive, we'll go down here and change colors. For the recursive, we need to define our first term, and in this case, our first term is our 0th term. To find every term after that, we'll take the one right before and multiply by 3. Number 3 can be super tricky. So the big hint down here at the bottom, work separately, then add them up at the end. So that's exactly what I'm going to do. First, I need to find f of 1. So f of 1 means that anywhere I see an x in the f function, I'm going to plug it in and I'm going to replace it or substitute in a 1. So 4 times 1 squared minus 3 times 1 minus 25. Well, 1 squared is 1, 4 times 1 is 4, minus 3 minus 25. So my f of 1, when I simplify this out, should be negative 24. The g of 0, so that now I'm going to plug in 0 into the g function. Negative 2 times 0 squared plus 0 minus 5. Well, anything times 0 is 0, plus 0 is still 0. G of 0 gives me negative 5. So now the question was, or the prompt was, to find f of 1 plus g of 0. We know that f of 1 is negative 24. We know that g of 0 is negative 5. So now we are looking to find negative 24 minus 5 gives me a negative 29. For number 6, the middle of two given numbers. A couple of different ways that you can do this. You can do this the hard way. I'm going to set up a number line and go negative 3, negative 2, negative 1, 0, 1, 2, 3. I know that I've got one of my points here, another point here. I need to try to find the middle point. So 1, 2, 3, 1, 2, 3. Yep, it's the same. The middle is 0. Or another piece that we can use is we can find the middle between them by averaging. So we can take the first term plus the second term and divide by 2. Well, 0 divided by 2 is 0. The second one, negative 4 plus 16 divided by 2. Negative 4 plus 16 gives me 12. So the middle is 6. And the final one, negative 14 plus negative 3 divided by 2 would give me a negative 17 divided by 2, which you could leave by that by itself, or you could divide it out and get negative 8.5. Hopefully this helps. This is going to launch us into Module 2. Reach out if you have any questions at all.